And this presentation showcases a hands-on project developed for Harvard University CSCI E90 Cloud Services Infrastructure and Computing. I will demonstrate an automated solution I built to validate FedRAMP 20x key security indicators using native AWS services. This project highlights how compliance validation can be transformed from a manual process into an automated, repeatable capability. I would like to acknowledge and thank my Harvard professor, Mr. Greg Misiko, and the teaching assistants for delivering an outstanding, practical, and industry-relevant learning experience during this course. In my role as a senior cybersecurity consultant working with multiple cloud service providers, I observed that automation for validating FedRAMP artifacts remains immature, forcing teams to rely heavily on manual, time-consuming processes. This project and this presentation is going to demonstrate how AWS native services can be leveraged to streamline, standardize, and automate FedRAMP 20x key security indicators assessments, significantly improving efficiency, consistency, and audit readiness. So the technology leverage here includes Terraform that was used to build and deploy the services. And then we also have AWS Lambda, step functions, DynamoDB, Amazon S3, and API gateway. This demo makes use of all this serverless orchestration to show how we can validate the KSI-CNA-05 logic as a use case for validating DOS or denial of service out of the 20 KSIs that FedRAMP has currently published. AWS step function is going to manage the workflow by pulling data, running checks, and storing results. Here is the architecture of the whole setup. This is deployed within a virtual private cloud, also known as a VPC. 2 subnets, 1 private and 1 public. A bastion host was used as a means to SSH into the private subnet for maintenance if needed. Core services were deployed within private subnets to enforce network isolation and reduce the system's attack surface. This design aligns with FedRAMP and Zero Trust principles and supports least privilege and network access control. An API gateway request initiates a step function workflow which coordinates the entire process orchestration, and then the Collect Evidence Lambda inventories relevant AWS resources such as WAF, security groups, and Route 53 and return structured evidence. Next, we have the Evaluate Rules Lambda, which applies the KSI-CNA-05 logic, determining whether required protections like WAF, DNSSEC, or open ports are available. This results and evidence are then persisted in DynamoDB and finally stored in S3. The Generate Report Lambda produces a human-readable compliance report and makes it available in S3. A live demo is going to show you how this works. We retrieve the API-based URL from Terraform output, trigger the KSI validation using a simple API call, and then confirm that the workflow executed successfully. Finally, we are going to validate the system, produce the auditable artifact by checking the step functions execution that is generated in the S3 and also recorded in DynamoDB. I'm going to SSH into the EC2 instance. Now I'm in the EC2 instance. I'm going to navigate into the KSI Terraform directory, and then I'm going to get the base URL for the API execute function using an echo command. Now here is the URL. The next step, I'm going to run a curl command to initiate the workflow. You can see the curl command has succeeded. So we have OK, and then we have the execution ARN and also the start date. So the next command will be to confirm if the workflow actually produces artifacts. So I'm going to run a step function describe execution command. Here is the output from that command. I will run the AWS step functions list executions command just to see all the latest executions that are available. So here's the command. All right, right here, these are the executions that have been registered. You can see all of them right here. Succeeded executions. And the next command will be a command to verify if the reports were recorded on S3 bucket. Okay, so currently we have 5 files that have been registered and recorded in S3 bucket. And the last command, we are going to verify if DynamoDB has registered the KSI results. I'm going to run this DynamoDB scan command. Here we can see the payload that was registered in DynamoDB. I go to the KSI S3 bucket, I click on reports, and you can see that we have the reports that have been deposited or recorded in the S3 bucket. I'm going to open the one that we just ran. Yeah, we can see the JSON file right here with all the KSI demo report and the timestamps, and there's the latest execution. We're also going to check the DynamoDB and run a scan. This prototype demonstrates that FedRAMP 20x key security indicator validation can be effectively automated using AWS native tools, dynamically reducing manual review effort while directly supporting FedRAMP's modernization objective of moving from labor-intensive documentation to a scalable, automation-driven compliance model. This work actually establishes a foundation for advancing FedRAMP 20x KSI validation towards a fully continuous evidence-driven compliance model. Future research can expand this prototype by integrating additional KSIs, also applying policy as code and risk scoring techniques, and enabling near real-time compliance monitoring across cloud environments. Such evolution is going to position automated KSI validation not only as a compliance enabler, but as a core capability for scalable federal cloud governance and risk-informed decision. And this is compliance as code, automating FedRAMP 20x KSIs using AWS native orchestration.